Today I am building a computer. So this is a 9800X3D. So everything I got over here is going to be built around this. For the motherboard, I'm using an ASUS ROG Strix X870E-E. For the RAM, I'm using G.SKILL DDR5. This is a 96GB kit. For cooling, I'm using a Noctua NH-D15 G2 LBC. For the power supply, I'm using a Corsair HX1500i. And for the hard drive, I'm using a Crucial T705. So let's start with the motherboard. So here's the motherboard. Kind of interesting, they actually gave us a little foam padding for it. Got something we can actually set it on. So it is set up for 4 sticks of RAM. We do have a USB-C, USB 3.0. We have 3 USB 2.0s here on the bottom. A couple fan headers. We got our audio, another fan port. It only has 4 SATA ports on it. So we got another USB 3.0 right there. Interesting, they actually put covers on the fan headers on the top. They did actually put an on switch right here on the motherboard. So if you got a problem with your PC button, or if you're just doing overclock and you don't want to have to reach around to the front, you can do that as a flex key. So you can set that in the BIOS. 2 8-pin CPU connectors. And it looks like we got another fan header right here by the CPU. So we got a keychain lanyard, got a fairly small instruction manual compared to what I'm used to. Got some stickers. Here's our Wi-Fi antenna. Got a couple of SATA cables, some extra covers for those headers, an extra thermal pad, some plastic clips for the M.2s, another cover, 2 more covers, zip ties, and a little thumb screw. It does label this as a quick start guide, so this is a small manual. Kind of a shame. I would expect a motherboard like this to come with a full manual, but I guess they just expect you to download that. So this does have 2 USB 4 40GB ports. Now it's going to be excellent if you want to use something like a Xike drive. You're going to have a lot of bandwidth going through one of these ports. So we have a 10GB port and we have a 20GB port. And this does have HDMI, but this is only going to work if the CPU that you're using has integrated graphics. There are 5 M.2 slots on this motherboard. There are 2 right here, there are 2 right here, and there's 1 right here. These 3 are 5.0, these 2 are 4.0. This one you can easily replace. All the other ones you have to take out screws in order to remove those heat sinks. Now there is a catch. These 2 plus the one you're going to be plugging your video card in, these all share bandwidth. It's not a huge deal, but if you want to get the absolute maximum, you're going to plug your hard drive in here and you're going to leave these 2 blank. If you have just the video card in, it's going to be a by 16. If you have a video card and anything else, it's going to be a by 8. This is a Crucial T705. The reason I wanted this is because this can go up to 14 gigabytes per second. So to my knowledge, this is the fastest hard drive that you can get. The catch is you do have to use a Gen 5 slot. So that means we do have to use one of these 3 here on the top if we want to get the full speed from this. So we will put this in the obvious slot. So there's a little slot right there. We just want to make sure that that is lined up correctly. Then you can pull a plastic tab back and drop it in. Our heatsink also has a thermal pad. So just make sure we get that locked in and then press it down. According to the manual, the switch is going to allow you to choose between PCIe 3.0 or 4.0. I'm just going to leave that in auto. Since we're going to be installing this cooler, we are going to have to change out some of the hardware on this motherboard, so I'm going to open this up now. I always use air cooling. I always use Noctua. They just make the best CPU coolers. This is an NH-D15 G2 LBC. What does LBC stand for? That stands for low base convexity. This is designed for AMD processors. If you have an Intel processor, you can get the high base convexity, so it's an HBC. If you want to get a cooler that's compatible with both, then you just get the NH-D15 G2 with no acronym on the end. So it'll just be cut off like that. So what happens with an Intel CPU, whenever you go to clamp that CPU down, it actually pinches right here in the center. So you can see it makes it convex. If you got the high base, then what it would do is it would actually match that convexity. The low base convexity is essentially going to make it perfectly flat because AMD CPUs will mount perfectly flat. If you get one of these without the acronym, so it's just a regular one, it's still going to have a little bit of convexity, but not by much. Realistically, it doesn't really matter. I just want to get the absolute best one I can get, so that's why I got the LBC. So this is actually compatible with both Intel and AMD. This one's just going to be better on AMD. And we got everything organized. So we got the AMD over here and we got the Intel over here. Actually, it comes with a fancy driver, and that is a Torx head on that. We do have some thermal grease and we have some connectors. And there is the cooler. Now, I always appreciate they put a little cover on there so we're not going to get any oils or anything on that surface. So we're going to start by popping out these screws. And then we can take these guys off. And you can see we got these threads right here, and that is a part of this plate that's on the back. So we got 4 spacers and 4 new screws. You just drop the spacers onto those threads. And for our mount, we can see we have a couple different positions for those screws. This one is labeled south, we have another one labeled north, and the reason there are extra holes is just in case you want to do an offset. So if you want to mount the entire heatsink down a little bit, we can use that offset. Alternatively, we just use the holes that are on the bottom, and that is going to be the standard mounting position. You can tighten those down. You do not need to crush these. You want it to be tight enough that it's not going to come loose, but not so tight that you're really squeezing that board. So if you look at the RAM, we can see here on the top, this is the layout. So we got A1, A2, B1, B2. So this is A1, A2, B1, B2. Since we're using 2 sticks of RAM, we want to use A2 and B2. So I'm going to pop those 2 clips. So this is Trident Z5. This is the silver color. This is 96 gigabytes. It's PC6400 and it's a CL32. You will notice this is an XMP. Even though I'm putting this in an AMD build, this will work fine. We just want to make sure we line up that slot with the notch that's on the motherboard. When you press that in, that should lock those tabs down. Okay, get our CPU installed. All I gotta do is pull this guy back. There's just enough clearance. Oh, maybe not. That's kind of annoying. So it looks like this plate is actually going to interfere with the operation of this flap. And there it is. We do have flat contacts on there. If you're used to building old PCs that have the pins on the bottom, you're not going to have that on this CPU. The pins are actually on the socket. The important thing here is you want to make sure that that triangle is lined up with the triangle on the socket. So you can kind of see the triangle right there in the corner. The other thing you want to be careful about is that these pins are very fragile. These are much more fragile than on old PCs. If you accidentally drop the CPU on them, you will probably bend them. So you got to be very careful with this step. And you can see the notches right here will also align. And we just press that guy in, and the CPU is installed. The Noctua actually came with this. This is a little guard, so we don't have to worry about getting thermal paste all over. Something I have never really seen or even had to use for before, but there it is. So all that's going to do is it's going to cover all the little openings there on the CPU, so you don't have to worry about anything getting in there, so you don't have to clean it up later. According to Noctua, that plastic is supposed to be able to withstand 130 degrees Celsius. That's going to be well above the TJ max. And for the M5, they say to put one large dot in the middle and then one small dot in each corner. So that is what we will do. Now, even that is probably too much, but we've still got plenty of this left over, so in the event that we need to reapply it, they did actually include a cleaning cloth, so we can clean all that off and try it again. Typically, these are just isopropyl alcohol. You don't have to use these, but it's nice they included that. So now it is time for the cooler. Now, the screws we're going to need to get to are going to be underneath this fan, so we're going to need to pop that off. We just grab this little spring, and then we can slide that out. So we can see on the bottom here, we got a nice clean surface on there, and that is super well polished. And these screws are actually little nuts, so when we screw that in, that's going to thread on the outside of these threads. And just to make this a little easier, I'm going to take off this fan as well. There is not a lot about building a computer that's complicated. If there's anything, it is this. This is the hard part. You want to just try to make sure that you're getting this done as straight as possible. And then we're going to screw these little threads in. And just go back and forth, make sure that you got even pressure. Okay, that one is stopped, and that one is stopped. So you can feel whenever you're done. And as you can see with this one, we have got plenty of RAM clearance. So here are our fan headers. If we look in there, we can see we got CPU fan, CPU option, AIO pump, and then chassis fan. So we are going to use these two headers for our two fans. We also have these cables, so if your motherboard only had one port, we could plug both fans into here, and then plug this side into our motherboard header. These two cables are low noise adapters, so all this is going to do is it's going to reduce the fan speed. So if your motherboard doesn't adjust that and it just wants to run at full speed, we can plug these in to make them quieter. They do come with a guard. And if we look on the top, we can see a couple arrows. So the fan is going to spin this direction and it's going to push air that direction. I want to push air that direction, so I'm going to install it like this. You can see we do have that cable coming out the top. We can rotate that so it'll be on the bottom or the top, whichever way you want. And those will just clip in on those fins. So this fan, you can see it actually kind of sticks up a little far. Right here, it would be sitting basically right on top of the RAM. I want this fan to go over here, but the clip is facing the wrong way. So we can just grab this and pop it out, flip it around the other way, and drop it in those mounting holes. Yeah, I think that's going to be standing up a little bit too high, so I'll just pop this fan off. So we will be using one CPU fan, which is not a big deal. With our header, you can see we got 4 pins, and then we got this little tab sticking up. We just want to make sure that tab sits right in that slot. Let's take a look at our power supply. 1500 watts is way overkill for this PC. It is overkill for pretty much any PC. I like overkill because what that means is that it's going to be running at a reduced mode for whatever that PC is actually requiring. You can see this is a platinum rated power supply. That means it's going to be at least 89% efficient. You're never going to get an output of wattage that's going to be the same as what you're actually drawing out of the wall. There's always going to be some loss going from AC to DC. But if you run at a reduced load, then the efficiency is typically going to be even better than that. And with this power supply, it might not even heat up enough to have to turn the fan on. So I always use Corsair just because they're reliable. And that's why I always prefer going overkill on my power supplies. So there it is. You can see we got a ton of different ports on here, and it does even give us a tag saying silent operation at low to moderate loads. So that means if you turn this thing on and the fan is not spinning, that is not a big deal. So we got our power switch, we got our power ports, and they gave us a nice thick cable for this power supply. They also included more zip ties, and we got some mounting screws. We've got a whole mess of cables. I'm used to Corsair including a little bag, so we got a spot for all of our loose cables. I guess we don't get that with this. We got our 24 pin. This is the only one that has actually got a braided sleeve for it. We got our CPU cable. You can see everything on here is labeled. We have 6 PCIe cables. Looks like we have a second CPU cable. We got 2 of our old style power adapters, 2 of the newer SATA adapters, and then we got a connector for our iCUE. You can see a bunch of these say PCIe CPU. Over here they say SATA PATA, and then this one up on the top it says motherboard. So for all these ports that say PCIe CPU, you can plug in either of these cables. So for the cables we're going to need, we are going to need our 24 pin connector. Never really did understand why they split these up. There's probably a reason for it, but I have yet to see a use case for it. And you can't see on here that some of these look like a D, some of them are square, so you can't really plug this in the wrong direction. We're going to need a CPU connector. For our graphics card, we usually use a PCIe. I'm going to be using 12 volt high power, so I have a different connector for that. Then I'll plug in my 2 SATA connectors right there on the bottom. So we have 4 total wires plus the 12 volt high power that I'm going to plug in later. And for this case, we can just slide that guy right in, and then we screw that in from the back. It's a very nice case because we actually have toolless design, so these screws are always captured. And I've got this Lian-Li cable, so this is what I'm using for the 12 volt high power. So those will just plug into those PCIe CPU slots. And then I got my other Lian-Li cable right here, so that's just pushing out the front. See the front side right there. And I'm going to connect the 24 pin from the power supply to that cable. That's an advanced setup. You don't have to do that. You can see I got a controller right here. I got wires going all over the place. You could alternatively just stretch this cable right around to the front and plug that directly into the motherboard. So now we can drop this guy in. Just want to make sure that we're not laying it on top of any of these cables. And we want to try to get it in line with those threaded holes. And there are 9 screws to attach that. So I got the cables already routed, so basically wherever the case cables go, you just try to route so it can be close to that port on the motherboard. Here's my USB-C. That plugs in. Got my USB 3. And that plugs in. I've got another USB 3 right here. This is the 24 pin. I'm going to be using just the M.2, so I'm not going to be plugging any SATA in right now. This cable is labeled HD audio, so that will plug in on the HD audio header. Got a chassis fan header right there, so I'll plug in these fans right there. This is USB. I'll plug that into the first USB port. And then I got 2 more fans, so I'll plug those in right there on the bottom. So I got one more important connection. This is going to be for our case buttons and lights. Now, quite often these are going to come as separate plugs. So you're going to have a bunch of different little individual wires, and you'll have to match those up with the pins on this connector. Fortunately, this has become kind of standardized, so we don't really have to worry about that as much anymore. So these 2 on the bottom left, those are the hard drive LEDs. We want the positive to go on the left. Next 2 on the right are the switch. It doesn't matter, there is no polarity, so you can have it either way. On the top left, we got power LED plus, power LED minus, and then we got the power switch. And again, with that one, there is no polarity. So just drop those connectors on there. On the top of the motherboard, we got our CPU port. You can plug in 2 CPU cables on here if you want to, if you're going to be doing some severe overclocking, or if you got a ton of cores. For a 9800, that's not going to be important. We can just plug in 1 CPU cable. It's a good idea just to go around and make sure that all these cables are tight, that they are seated all the way. And the last thing is this 12 volt high power. Okay, power on, and let's see what happens. So I am currently getting an error code 15, which means that there is a memory problem. So it could be that I got bad RAM, or it could be that I need to update my BIOS. So I'm going to put my BIOS, which I got loaded onto this USB stick, into the BIOS port. And we're not going to turn the power onto the computer, but we are going to hit the BIOS flashback button right here for 3 seconds. You can see there's a little light blinking right there, so it's letting us know that it is updating the BIOS. If the light goes out and it stays solid, then that means the BIOS is updated. If it turns on and stays solid, that means there was a problem with the BIOS. Okay, light is out, so we should have the newest BIOS. So we got past the 15 and we are now booting. So that's something you might have to keep in mind if you got this motherboard, especially if you got this RAM. So there is the BIOS. So we got everything right up here at the top. Go to advanced. So I can see right now on the processor we are at 4700 megahertz, and that is at 29 degrees. So nice and cool. The RAM is currently at 5600 megahertz and we got 98 gigabytes. So 31 on the CPU, 42 on the package. Motherboard is 24 degrees. VRM is 29. So that is excellent. So go to AI Overclock Tuner, change this to DLCP1. So here we can see it, DDR5 6400 with a cast of 32. Now let's go to exit, save and reset. And this is going to tell us exactly what it's going to do. So it's changing it to DDR5 6400, TCL to 32, and most importantly, it's turning the voltage up to 1.35. So it needs to pick that voltage up so it can increase that speed. So very nice, it'll do all of that automatically. So it took it a minute to take that. It just stayed on 15 for a while, but it just had to relearn the RAM. You can see the CPU is running at about 400. The chassis fans are all running about 700. So now it's time to install Windows. And it's going to plug that into the back. It does not matter which port you put that in. And save and exit. Okay. And there we go. So if you ever installed Windows before, you're going to be looking at the same thing. Oh, do not meet minimum system requirements. Okay. All right, and hit yes. Well, let's try that again. Okay, so that worked. So this is our new drive. And install. And now we wait. Okay, US. And we'll plug in the Ethernet so we can connect to the internet. Leave these on if you want. I usually turn these off. Okay, all right, cool. And we will get the DriverHub. You don't need to get the DriverHub. This is something that comes from ASUS. It's kind of neat that we don't have to plug a USB drive into it. So apparently everything is already loaded into the motherboard. That's also a little bit scary. So the first thing I always do, I always like having the start bar on the left. So I'm going to set that to the left. Next thing I want to do is check for Windows updates. And there are a bunch of them. So I'll go ahead and let those install and then we'll come back to it. So let's go ahead and do a speed test on that drive. Okay, so pretty darn excellent numbers for that. Looked like we had 63 degrees Celsius when we were reading and a max of 66 degrees Celsius when we were writing. Right now the temperature is 52 degrees and it's still writing. Sequential 1 8 process 1 thread, we got 13677 and 11988. Sequential 1 8 1 process 1 thread, we got 8400 on the read and 10,000 on the write. For the random 4K 32 process 1 thread, we got 827 and 540. And for random 4K 1 process 1 thread, we got 76 and 291. So excellent speeds there for that crucial. So let's do a CPU multi-core. This is going to test the processor speed. Okay, so that did get up to about 92 degrees. The max that this processor can go to is 95 degrees, so it did get pretty close to that, but most of the time I was hovering around 86 degrees, so that is perfectly acceptable for that processor. Keeping in mind that when you're doing games and stuff like that, you're probably never going to see a temperature like that. This is basically a burn-in test for that processor. What I really like to see here is this number right here. We got a 1283, so that is above a 32-core Threadripper. That is just below a Xeon, which is a server processor. So that is an excellent score. So last thing I'm going to do is I'm going to use IM disk to create a virtual disk. That's what I got right here. And we are going to do a speed test on that. So this is essentially going to test the speed of the RAM. It's not a perfect test, but at least it'll give us an idea. Okay, and there we go. So that's actually pretty cool. The hard drive is almost keeping up with the read speed on the RAM. So we got 15 gigabytes per second on the read, and we got 25 gigabytes per second on the write. So that is some super fast RAM. I was wondering why my strips weren't lighting up. It turns out I had a USB unplugged on this USB too. So this is for that Lian-Li controller. Okay, so let's see what happens now. There we go. So we have got all kinds of RGB in there now. All right, yeah. So beautiful computer. Super fast, real pretty looking. I look forward to playing with that.